They do it all and they do it really well. Okay, no expectations now. I've built you up massively. So cool. Thanks, David.
Thank you. And to reiterate that, if the point of the Maths Learning Centre is if at some point you see maths somewhere in some course, any course, and you feel that talking to someone about it would make it better, then that's what the Maths Learning Centre is for. You can come and talk about any maths that appears. And so it could make it better because you think this is less fun than I would like, and maybe they can make it more fun, or this is scary, they make it less scary. I feel funny about this, maybe they can help me feel different, or I just want to talk about it. At any moment where the maths appears, you can have a chat about it. If you're not sure if it's the maths or the chemistry that's the problem, then we can help you figure that out too, and figure out a nice question to ask the people who teach the chemistry that will get the information you need if it is the chemistry that's the problem. So you know where it is. It's pretty much directly above us. It's on level 3 of Hub Central. Maybe a little bit that way, and then directly up. So if you go up any of these stairs around here, you'll be very nearby. It's on level 3 of Hub Central. Writing Centre's right next door. The Biology, Chemistry and Physics first year drop-in centre is just there as well. It's a place to go. If you stand in there, someone will say, hey, you're looking for help with something. So there you go. That's the spiel, and now we'll do the actual thing. So we're going to be looking at data today. But before we actually look at any data, and I'm going to have a little chat about some of the things we need to know before we can look at the data. So, data is, it's a measures statistics. Mentioning data means that we're thinking about statistics, and the first thing I need to say is that the purpose of statistics is for answering questions using data. And when you do statistics, you do things like calculating numbers, like percentages or means or standard deviations, drawing graphs or graphs if you prefer, performing statistical tests or calculating mathematical formulas for predicting things. All of that is statistics. And if you do a statistics course, like a course with statistics in the title, you will learn a little bit of all of those things. Today, we're just talking about the drawing of the graphs. That's just today. But all of these things are statistics. So in order to understand what the graphs are doing, we need to think about the kinds of questions that statistics can help with, because it's designed to answer questions. So some questions that statistics can help with are about a single concept. So for example, how much salt is there in an avocado? That's one idea, amount of salt. How many chapters do novels have? That's one idea. How much cloud cover does Adelaide have in March? That's one idea. Do the majority of ice creams have the amount of fat in them that the nutrition information says? One idea, the amount of fat, and whether it's equal to something or not. So I've going to draw all concepts as little clouds in pictures. If you ever see me help with any statistics courses, I will use this in those as well. So keep an eye out for it if you're doing Statistical Practice 1 and you look at our resources on the web page. Now, some questions are about one concept, but almost all science questions are actually about the relationship between two or more concepts. So, for example, are science fiction books thicker than other books? The two pieces of ideas that are there are the genre of the book and the thickness of the book. These two things here are not two different ideas, it's just one idea. What kind of book is it? How much of an effect does more sleep have on a student's grades? We have sleep and grades, those ideas. They're the concepts that this question's about. Does chili in a meal make a difference to your body temperature? Chili and body temperature, they're the ideas here. And can you predict the air temperature from the amount of cloud cover? That's cloud cover and temperature. They're the concepts that are going on here. So most questions that you could ask that are a sciencey question, or indeed any question, are usually about the relationships between concepts, and most science questions are actually the relationship between more than two concepts, but it's easier to deal with two. Okay, for statistics to be able to help, you have to turn your concepts into variables by measuring them. Statistics is not capable of dealing with concepts, they're too vague. We need to have measurements. So here's my example. In the question, does chili in a meal make a difference to your body temperature? Chili could be measured in multiple different ways. I could say whether a meal has chili in it or not. And the answer to that is yes or no. Now, the yes and the no, they're not separate variables. They're two aspects of the one variable, which is whether you have chili. So that's one option for how I could measure chili. I could also measure chili as mild, medium, or hot, which is one variable that has three categories. Or I could write down the exact amount of chili powder added to the meal during cooking, and that would be a number. When you choose how to measure something, your concepts become variables. And I draw variables as nice little neat rectangles because we can know exactly what they are. Statistics is not able to answer questions about concepts, it's only able to answer questions about variables. And the big idea in science is that you have to decide how you're going to measure your concept. And you have to decide in the way that's going to be most useful for you to answer the question. But you do have to decide. And any of these three choices are perfectly acceptable, but you'll get different information out of them. And that's one of the things that you've already talked about and you will continue to talk about in science or fiction. Okay, so where have we been? We've had concepts and questions, and concepts become variables when you measure them. There are two kinds of variables and they make a big difference to how you can do statistics on the results. One of them is a categorical variable and the other one is a numerical variable. Categorical variables are generally words and numerical variables are numbers. And that's the main difference. In some I call them categorical, but in some courses you might hear them as qualitative variables. And I call them numerical variables, but in some courses you may hear them called quantitative variables or interval variables or scale variables. Different disciplines within the university, different lecturers, even in the same discipline, will use different words for them. So I've just given you all of the words that might possibly be used. I'm going to call them categorical and numerical. So you can tell the difference because numbers, how far apart they are, mean something. If I have group 1 and group 2, they are not one apart, they are just different groups. And so that difference between them isn't really real. So group 1, group 2, that number isn't really a number, it's just a word. It's just a category. Last thing on this slide is that when I draw these diagrams of what the relationship we're interested in, the categorical variables I draw with boxes to say, oh, we're putting things in boxes, and the numerical variables I draw with a little line with strikes on it, which is the scale on which I've measured the number. So that helps me visually to make sense of what's happening. Okay. We're getting there. So, the last piece of terminology and the piece of philosophy here is the idea of subjects. So in science, in an experiment, the things that you measure stuff on, they're called the subjects of the experiment. They could be, well, we'll talk about that. And that's true in statistics as well. Whatever object is producing your variables is called a subject. And to a statistician, they don't really care what the subjects are, just that they produce variables. And if you're going to type all your data into a computer, the computer doesn't know what the subjects are, it just knows that there's things typed in the sheet. So, for example, we could have a banana, and I could measure the age of the banana, like the time since we picked it. I could measure the weight, I could write down the variety of the banana, and I could write down how much potassium it contains. And there are lots of questions I could ask about those variables. I could say, does one variety of banana have more or less potassium than another? That's a relationship, for example. Obviously I would expect the weight to affect the potassium, because a bigger banana ought to have more. And so those things are all related in some complicated relationship. Age and weight and potassium are all numbers, they're numerical variables, whereas variety is a category. But to a statistician or a computer, there are not bananas, there are only sources of variables. I could have people and I could give them all a meal with chili or without, which is a category with two options, and I could measure their body temperature afterwards. And to my computer and my statistician, there are not people, there are just sources of variables. I could have a situation where I'm going to have the culture medium in a petri dish, different kinds of things to grow the bacteria in, and I can give them a treatment or not give them a treatment. Maybe I put penicillin in there or some fancy new antibacterial agent, and I can count how many bacteria colonies there are on each of 3 different days. Those are all variables that belong to that petri dish, and 2 of them are categorical and 3 of them are numerical. And I can even calculate a new variable and combine those three numbers into a growth rate, and that's a new numerical variable that still belongs to the Petri dish. Just because I calculated it from the ones I've already got doesn't mean it's not a variable that belongs to the Petri dish. They all belong to the Petri dish. But again, to the statistician and the computer, there are not Petri dishes, there are just sources of variables. And finally, your sources of variables don't have to be individual objects. They can be entire groups of objects all at once. So I could have 1, 2, 3, 4, 5, 6, 7, 8 people, and I could write down, you could have a whole group of people that all have chili or not chili in their meal all at once, and I could write down the mean temperature of all 8 people, and I could write down the percentage of people that have a temperature above 37 degrees. And that mean doesn't belong to any one of the people, it belongs to the entire group. And that percentage doesn't belong to one person, it belongs to the whole group. And so, in that sense, my entire group is the subject, not any one individual person. And that's important, and you will make that switch of perspective quite a lot in a lot of statistics and in science as well. But that's what subjects are. Okay, got an activity. I've already given you a collection of subjects on little white cards. And they have some variables written down on the cards already. And what I'd like you to do is decide if the variables that are written there are categorical or numerical. They're going to need names. So like the banana had variety, you're going to need to give a name to those so that if you ever put this data into a spreadsheet, you would have a title for each column. That's what we're thinking of there. And then once you've decided if they're categorical or numerical, you might think of other variables that you could write down about those subjects that I haven't written down. Things that you might want to know about, well, they're movies, okay? Things you might want to know about those movies that are variables that you could write down, and you should decide if they're categorical or numerical as well. And then, after you've done all of that, think about some relationships that might exist between those variables. So think of 2 of the variables and go, how might they be related? Okay, that's what we're doing for a little bit. I'll let them go for a couple of minutes.
Which is hence why we got into how are we doing? Very gang with the license. Or part of why something like that wasn't planned. Yeah. Or was it planned to be? And then it was bombed, so they just did it. Like the Incredible Hulk.
All of the Hulk.
Actually, Hulk just never. He works okay as like in a group, but by himself.
Okay. We've had a chat to all of you and you've done a very good job of deciding what kind of variables they are. Well done. And we've heard some really cool other types of variables that you might write down. Off the top of my head, I can't think of any right now. There was, oh yeah, what Andrew rates the film out of 5. That was one.
No, there's also ones which were whether it's a sequel or not,
Yep.
or whether it's part of like a continual arc or it's a standalone movie.
And this group over here was saying that you could write down which number in the sequence it is, and that would be numerical. But you could also write down whether it's a sequel or an original, and that would be categorical. And so you get to choose how you write that information down, and it changes whether it's a category or a number. Okay, so you had a really good look at this data. We're going to look at it more as we go along. Okay. Right. So now we're going to choose a relationship between the variables. So for example, you don't have to choose this one. And I'm actually going to pick 2 variables that aren't on the list. You could choose the number of actors in the film and see how that's related to the budget for the film, for example. That's a sort of thing that you could investigate. You can't because you don't have that information. But you could do something similar with the variables that you have. You could also do something like, I wanted to have some categories. Whether it passes the Bechdel test, which is... Sorry, yeah. Whether it passes the Bechdel test, which says that at least one woman has to talk to at least one other woman about a topic that's not a man, whether that happens, and whether it has Chris Hemsworth in it, and see if they're related to each other. Okay, so that's the sort of thing that you can investigate. What I'd like you to do is arrange your cards on the table to show how your 2 variables that you've thought of are related to each other. It has to be that when someone walks up to the table and you tell them which variables that you're looking at, they should be able to look at the table and go, oh, that's how they're related. Okay. And then once you are happy with your arrangement, go have a look at what the other groups have done. Has to be things on the cards though.
Well, you want to do it so when you look at it, and then put them in like, the bottom one is to make the least money, so so when you look at it, you go, oh, where does it all come from? So I think what you're doing is you're creating the number or the amount of money that you earn. So just split it so I just trying to visually be able to see.
April, May, billion. Yeah. Yes, that's what I'm saying. Oh, that guy.
Okay, either make lots of money or only be. Yeah, so that's the other thing. That's something that you don't know. What was the production? To get lots of money, we'll make lots of money instead of trying to but then you've also got the budget you can get and then so you're trying to see what other people have done if you're working out.
It's actually kind of not. It does. It does. And then you turn it over and feel like
I reckon everyone's about ready to go and look at what the other groups are doing. Get up and go have a look and see if you can figure out what relationship they've been drawing.
That's actually pretty good.
I hope these tables work.
No one's gonna understand it. I'll say this. just sit down. No, but just get it straight away. Oh, yeah. This one about. That's such a good idea. That is so smart. Are you serious? Explain it so well. No, I'm not focused. This also got me. I'm not sure.
So that belongs to the month. So that means the subjects are months, which is fine.
Well, actually, I don't know. It was.
I'm really glad that one is still true.
Stop it.
It's worth talking about. All right, everyone, I know you're having a good look at them, but I'm going to have to get you to go back to your table. Just can't see it.
No, I know what it is. I just need to think about it.
You would tell where it is just by looking at it. All right. Doing well. You've all produced some quite different arrangements. And your lecturer's not listening. All right. You've done a really good job. I would like somebody to say something that was difficult about this task. Criticism, yes, that's a perfectly acceptable thing. Unfortunately, you're going to have to deal with that in science. I was trying to be nice criticism. Sorry. Yeah, sorry. I better work on that. Yep. So can I just repeat that to see if I've got that right? The arrangement you chose to do was too complicated to achieve in the time you had? Yeah, that's reasonable. That's a very hard thing. Cool. Thank you. Very brave of the two people who said that that's something they struggled with. It's an important thing to be able to admit at university. So it is hard, though, sometimes to represent the thing that you want. Some of the teams, when the other teams arrived, the other team couldn't tell, even when told what the variables were, what was going on. And so it's really hard to represent that sometimes. So if you want to talk about a relationship of some number being higher, then you need to arrange them so that you can see whether one of them is higher or not. So you need to arrange them that way. And a lot of people solved that problem by lining them up next to each other, and that was great. And there are lots of other things as well. I was very happy with this team as well for creating a variable of their own, which was they had the box office takings and they went, I'm just going to create a new categorical variable as whether it's over 1 billion or not. But I will say that if you can avoid having to make categories, then it's usually a good idea. But we'll get back to that. But I was very happy to create a new one because then I could talk about that. So that was nice. So what I'm going to do now is talk about making graphs and not doing it with cards, but getting a machine to do it for you. So I'm going to head over here to this document. I will tell you as well that this document is on your page of the Maths Learning Centre website, which looks like this. And it has all the stuff that we've been using today there, if you're interested. Okay. So I'm going to walk through several sets of data and create graphs from them using Excel. I'm going to say right up front that if you have already learned a different way of producing graphs, like a different kind of computer program like R or GenStat or SPSS or any one of the other 13 programs that are in use at this university, then that's fine. Okay? You don't have to use Excel. But I'm going to show you with Excel. So Excel is designed to draw a specific kind of graph, and it's the first kind of graph that was ever invented back in the 1750s. And it's a line graph. Here is some data. It is the month and the average cloud cover in Adelaide in that month, measured in octas, and an octa is approximately an eighth of the sky. And so 5/8 of the sky are covered in May on average. And this is from the Bureau of Meteorology website. So I'm going to just ask it to draw a line graph. Insert a line graph. And ta-da, it does the job. Excel is specifically designed to draw this kind of graph as its first choice. We have along the bottom here the months, and this height is the number of octas, and we can see without having to read any numbers that the cloud cover goes down and then up and then down again. So the months there, that's a categorical variable at the moment. It does come in an order, and I could treat it as a numerical variable if I wanted, because these are 2 months apart and they're 1 month apart. So I could treat it as a number if I wanted, but at the moment it's a category because it's listed as words. All right, so there you go. That's what a line graph was for. Invented in the 1750s by William Playfair and used to this day, especially Excel, which is designed to do it. I could also draw a different kind of graph, which was also invented by William Playfair, which is a column graph, and I can switch this to a different kind of graph if I want. And change it to a column graph. And now, instead of just a dot at this height, there is a bar that goes that high. And this one, you might feel better about this one depending on your perspective, because you might think, oh, look at, a higher amount. I'm thinking that there's a total amount of cloud cover that could possibly be, and this is how far it is, and it feels like it's covered, so it's a bar. That might feel better for you, or maybe not. I prefer the line graph in this context, because it's a little easier for me to see based on the slope of the line whether it's going up or down. You get to choose what kind of graph you want. No, not that one. Okay. I'm going to do this one as well. So it may be that you have more than one object upon which you're measuring information. The object we're measuring information is the city of Adelaide here. We might have more than one object, and you want to have a line for each of them on the graph. So these are orange trees, and we've recorded their circumference. I think it's in inches, could be in centimetres, on each particular days of their growth. And so if I did this, I could get tree number 1 with a graph of its own. And I can see that tree number 1 grew. Beautiful, that's productive. But if I select it all, I get, oh crap. I don't have the line that tree number 1 had before. It's not here. What's this doing? Oh, this is tree number 1 here, and this is tree number 2 here, and this is tree number... That's not what we want. We don't want our lines to connect each tree. So I'm going to switch the row and column. Ta-da! And now it's producing the graph I want. And so tree number 1 is still here, but the other trees are there as well. And I can see that each tree, they all grew, but tree number 1's actually in the middle of the others in terms of how quickly it grew. Excel automatically chooses the colours, and you might not be able to tell the difference between them, so it is possible to change them by clicking on that and going to format this thing, and you can change the colours. Black. And it didn't do anything. Of course it didn't. That would be too... Oh, there it is. Yes, it is green now. And you'll notice the dots didn't change colour. I have to change them separately. Changing colours on Excel graphs is painful, but there you go. Okay. All right, so I'm going to say a couple of more things here. These things here, because they have the word day in them, they're being treated as categories at the moment, which may be a problem because day 118 and day 664 are not the same distance apart as day 664 and day 1231. And so that might make a difference to how you interpret this graph if we were able to do that. But we'll come back to that later. All right. So I'm just going to say there's 3 variables on this graph. There's which tree it is, there's which day it is, and there's the circumference. And it's okay. And usually colour is what distinguishes a 3rd variable on a graph. Okay. Here's my 3rd set of data. This is a brakes test for cars in about the 1950s. The speed is measured in miles per hour because we're in the 1950s. And what happens is the car goes a certain speed and then it slams on the brakes and we measure how many yards it takes to stop. And so that's what this is. And so this is a little different. They're both numerical variables this time. And I would like something that indicates to me that when the speed is higher, the stopping distance is higher. That's what I'd expect to happen. And so that's all the data. I don't want to insert a line graph. I'm going to insert this. That's a scatter plot. And so each dot there is one of the cars, and what it lines up with on one axis is the speed, which is the bottom axis, and what it lines up with on the other axis is the stopping distance. So this car here has, I should point to that on the screen so that people who are not in the room can see it. This car just here has a stopping distance of, a speed of about 14 miles per hour and a stopping distance of 80 yards. And this car just here is this one. It's got a speed of 4 and a stopping distance of 2. And this car just here has a speed of 10 and a stopping distance of 18. So that's this dot just there. So each car is on the graph. So to a statistician, the scatter plot is the most fundamental kind of graph, even though it was invented like a couple of hundred years after, maybe 100 years after the first kind of graph. It's the most fundamental because every individual object is on the graph exactly once. Each of those dots is one car. Whereas back on the line graph, each line is one tree, and each tree is on the graph 4 times. And so that's a little more complicated than this one. Okay. So could someone tell me if this confirms the hypothesis we had? Does this confirm what you think should be the relationship between speed and stopping distance? Lots of people are nodding. Yes. Thank you. And why? Someone said something and I want to hear it. Can you interpret that in terms of what's on this picture? So the faster you're going, the further your stopping distance. So if you're the number for what's on the x-axis is higher, then so is the number on the y-axis. On average, though, right? Because it's not exact. It is possible to be going at speed 20 and have a lower stopping distance than someone that's going at speed 15. That's possible, but on average, it's more in both directions. Okay, cool. Here is another set of data. These are 592 students in a statistics class in about the 1960s, somewhere in the USA. I can't remember the details. And what we've written down is for each student whether their hair is blonde, dark or red, where dark is anything that's not blonde or red, so brown or black or all other possibilities. And their eye colour is in 2 categories of blue, hazel or green, or brown. Okay. And this is every person and what they have. All right, let's give it a go. I don't know. What do you reckon? I'll try a scatter plot. Nothing. Okay. That's because a scatter plot is supposed to be drawn with numbers, and these are categories. And Excel can't cope with that. R, if you use R, it can cope with that. But it still wouldn't be very helpful because we might have like dark red and blonde and brown and blue, hazel, green, and then a person who's dark and blue would be here, and all the people who are dark and blue would be there on top of that same person in the same spot on the graph. And so that wouldn't be helpful at all. We need something else. Oh, and it's also way down the bottom. Whoops-a-day. All right. Someone's made a suggestion of a bar chart. Can you tell me more about that? Pie chart. Cool. A pie chart would be cool, but I think it can only show one of those categories at a time. The pie chart could show me the blonde dark. It could show me the hair color or the eye color, but not both. Yep. Stacked bar graph. Tell me more.
You have all the hair colours in different bars, and then you colour the amount of bar.
Okay, so you're thinking something where there's like a bar here for dark-haired and a bar here for blonde and a bar here for whatever. Okay, cool. Right. So the height on that graph would be a number of some sort, which would be how many people. That number isn't in the data at the moment, and it doesn't belong to any one of the people. So I actually had to create a new set of subjects that is groups of people instead of individual people. So I'm going to set that up. Dark. Just a second. So you were saying you wanted some blonde, and red, and okay. And this would be cool. The blonde, I could say how many blue, hazel, green, and how many brown they have, and so on. All right. I'm going to have to count them. Excel is capable of doing that. There's a fancy pivot table thing, but I don't know actually how it works, so I'm going to count it myself. I'm going to count if a particular situation is satisfied. So I'm going to count these ones. Crap. If they are equal to blonde, and I'm going to count these ones. Whoa. If they are equal to blue, hazel, green. And there's 120 of those people. And Excel's really good. It will copy formulas. If you copy them across with that little green thing, it'll 0. Oh, crap. It's pointing at the wrong data. The blue moved over and the purple moved over when I did that. So you can literally move them yourself if you like, so that they're pointing at the right thing. And then that. Oh. Ah, that's there. Yes, okay. Now that's good. Or I can prevent it from moving things like this. I want to keep this thing in exactly the same spot, so I'll put $signs next to the cell references so that they don't move when I copy the formula over. And I want the hair color to stay in column F, but I'm okay with it moving down the row, so I won't put a $sign on the number. And I want the eye color to stay in row 1, but I'm okay with it moving columns, so I won't put a $sign on that. And now it's looking good. Okay. And it is pointing at the right things. Yep, and this one's pointing at the right things, so it's looking good. So now I have new subjects. I have 6 subjects. My subjects are groups of people which have different hair colours and eye colours. And I can attempt to draw a graph. Let me put a bar chart in. So you wanted this sort of thing. Okay, this one's a stacked bar chart. It says that there's like 120 blonde people with blue, hazel, green eyes, and then a few people with brown eyes, and similar to this, and the other one as well. It is sometimes a little hard to interpret a stacked one because you can't really tell how big this is without subtracting these numbers. So it's also sometimes a good idea to change it to just an ordinary one where they're next to each other like that. So, would someone please describe a relationship between eye colour and hair colour? According to this graph for these people in the 1960s at this university. Not this one. Dark-haired people predominantly have brown eyes, you say? I think the orange is the brown-eyed people. And all of these are the dark-haired people. Or did you? Yeah. So I think it's actually that they still have slightly more likely to have blue eyes. But that might not be true in the whole world. It's true at this American university in the 60s. I actually would think that dark-haired people are more likely to have brown eyes if you looked at the entire world. Yeah. So these are different hair colours, but it's definitely true that blonde-haired people are very unlikely to have brown eyes, according to this. Now, I can look at it the other way around if I want as well. I can switch the rows and columns and look at the eye colours and which hair colours go with them. And now we're saying that brown-eyed people are much more likely to have dark hair, which is possibly the thing you were hoping to say. Yeah. But so are the blue-eyed hazel green people more likely to have dark hair. It's just that people generally are more likely to have dark hair than any of the other two colours. Okay. Sweet. Here we have our second last piece of data. These are guinea pigs, literally guinea pigs, and we are giving them vitamin C, either in tablet form, crushed in their food, or as orange juice, which is further down, and we're giving them either a low dose or a high dose of vitamin C. There is a description of exactly how much vitamin C that is if you look it up. And we're measuring how long their teeth are, it looks like in millimetres, after a certain amount of time of being on this diet. Does anyone know why tooth length would be related to vitamin C? Bones? Could be. I'm pretty sure teeth aren't bones, but it's a good start, and you're extremely brave to say something. See, I did an assignment on vitamin C in Year 9 Health, and so I know that vitamin C is good for gum and tooth health. And I also know that guinea pigs are one of the only other animals other than humans that don't make their own vitamin C and have to get it from their diet. And so that's why guinea pigs would have longer teeth if they have more vitamin C. That's what I'd expect. Well, let's see. Let's look at the dose, maybe. Oh crap. It's got the numbers from 0 to 40 on the bottom here. It does not have low and high. Oh, that's the actual literal which guinea pig it is. The first guinea pig has a tooth length of 4.2. The last guinea pig has a tooth length of 27-ish. That's not useful. It doesn't tell me anything about whether the dose was high or low. I suppose these first several are the low, and then there's high, and then there's low, and then there's high. So I can make a guess, but it's not really telling me anything useful. Okay, so it didn't know how to deal with that. It didn't know how to draw a scatter plot and use categories. It never knows how to do that, so we don't want to do that. Let's try something else. Okay, that's slightly better. It's told me every guinea pig, whether it's low or high, and what its tooth length is. That's great. Not that useful. In fact, I reckon what we need to do is what we did for the bar chart, and actually not have the individual guinea pigs as our subjects, and just have the groups of guinea pigs as our subjects. So I want an average here. So I'm going to do the average of each group. I could measure lots of things. I could do the median of the group. I could do the maximum. I could do lots of different things. I'm going to do the average. And I think it's probably quicker for me to just select them because I can see where they are. This is going to be annoyed at me. But I'm just going to move the thing it's looking at to the right spot. No. I will tell you that in the same way that there was a sum ifs, just trying to make you feel sick. In the same way that there is a sum ifs function, there's also an average ifs function which you can tell it to do as well, but this was easier today. So these are our averages. Now we have 4 subjects, and the subjects are the groups of guinea pigs, and I can get it to draw what? No, it never likes scatter. No, okay. Should have told myself. It never likes scatter plots when there's categories involved. So I need to draw something else. How about a line graph? There we go. All right. So these are the guinea pigs, the average of the guinea pigs on the vitamin C at the high dose. These are the average of the guinea pigs on the low dose of the OJ. And I can see how those groups are related. I don't like those lines. I don't feel like connecting the low and high is useful because I really want to compare low to high. I want to just switch the row and column. Yes. Okay. Orange juice feels like something that should be compared, and it's also drawn in orange, which I appreciate. So the orange juice, if you're on orange juice, if you have a low dose, you have a low tooth length, and if you have a high dose, you have a high tooth length. And if you have a low dose of vitamin C, you have a low tooth length, and orange juice in general is better than vitamin C. Now the individual guinea pigs are not on this graph, and it may be that some guinea pigs on the low dose of vitamin C have a higher tooth length than the guinea pigs on the high dose of vitamin OJ, but we can't tell that. We've just got the averages here. I wonder something. I just want to try something. No. Just wondered if it would. Sometimes if you do the wrong, the graph you don't want, but it's the right shape and you switch to the other, it keeps the categories, but it doesn't today. Okay. So I'm going to say one thing, that we have lost a lot of information about these guinea pigs, and what most people would do is to draw little error bars on here. So I could go to the graph and go design and add error bars. And lots of people would choose standard deviation, but don't choose standard deviation because it doesn't actually know what the standard deviation is, because it's making that up. So I would just choose my own error bars and go to custom and tell it where the right numbers are to use for that. And I would have to literally calculate them. I would have to do a standard deviation for each group separately and tell it where to look for those. Yeah. And if you ever want to do that, then feel free to ask me in the Maths Learning Centre or someone else who knows about how Excel works. Oh crap, it's got them on there, but it's making up those numbers, so I will remove those. Okay. Before I do anything else, I'm just going to keep track of where we've been. So we talked about the line graph and the column graph as being able to have a category and see what number goes with each category. The line is usually to try and indicate that they all belong to the same individual subject. And it doesn't have to be categories, actually. It can be numbers on the bottom as well. And in fact, I'm just going to, now that I mention that, I'm going to go back to our orange trees, and I'm going to remove the words so that Excel knows that they're numbers. Now that won't stop it from thinking they're categories, because it always thinks things are categories, because that's what it's designed to do. But I can change the chart type to a scatter plot, and it'll do that. Actually, no, that didn't work at all. Let me go back to the line graph. I can change it to be a scatter plot with connected lines. There we go. And now it's interpreted those numbers along the top as actual numbers this time. And I can see that this gap in the middle is wider than the gap at the end. Anyway, that was the last thing about those graphs. So we have the line graph and the column graph. You can do a line graph with several subjects, and that's fine too, and each line represents one of the subjects. You can do scatter plots, and scatter plots in general are designed for 2 numerical variables. It is technically possible to do it with categorical variables, but you've got to do a little bit of fun, and Excel just will not do it. Bar graph, which is generally designed to talk about an amount of individuals in a group. But to do it, you have to tell Excel what those numbers are. It can't do it from the original data. Something like R or SPSS will be able to figure that out itself. And a line graph of means, same deal. Because you've changed the subjects to be groups, you're going to have a new set of data in order to draw that graph. All right. So, before I move on, I think that at least some people ought to have questions in their minds, and I would like them to ask those questions. I would like there to be 2 questions. Yes?
With the things you did to make it so you can count all
Yep.
the ones, do you know where we can find that? Like, can we have the document, or do we just find it online? So we can do it in future?
Yeah, in the end of the week I'll have the finished version of this, and I'll pop it on the website as well. But you can always ask me.
Also, this session is
being recorded.
so it's going to be up on Excel.
So those
A
are,
lot of people probably they're going, oh crap, I can't remember, I didn't write it down.
those are very productive questions. All right, one more question. I asked for 2. Yep. What language is the best for data manipulation? Well, that's a little bit like which of these movies is the best. Different people have different opinions. I really like R. Mainly for 2 reasons. One, it's free. 2, you can still get help for it online. It's an excellent R Twitter community. You just do it hashtag #RStats and they'll answer your question. And actually there's 3 reasons. If you want to know how to do it and someone's got the code that you type, you can cut and paste it and put things in the right spots. So I prefer R, but you can use whatever you want. A lot of people use MATLAB for that sort of thing as well, or Python. But I don't know how to use either of those, so R's my favourite because it's the one I know how to use. And the ggplot2 package in R is really rather fabulous for drawing graphs. So I love it. And it's also designed so that the colours it chooses are colourblind friendly, which Excel does not do. So there you go. That's my answer to that question. Okay. Andrew doesn't care as long as the graph shows the thing you want it to show. Yeah, like for your assignment.
I do care, but
If someone really wants Excel, you can actually you can set the theme in R to produce graphs that look like they came from Excel, if you wanted.
one thing to be honest, I would even accept hand drawn, but that's a lot of effort. So if you do have a level of proficiency in whatever, it's great. Going on in science, you will have to take graphs, make graphs. So, you know, you could use Excel, you can use R, you can use Google Docs. Other people
So pretty much all of these functions are in Google Docs as well. Yep. Yeah, so your Microsoft Excel and Word and whatever for free, that's what you're saying? If you're not sure how to do it, there's a drop-in area for tech support with a big orange table on level 3 of Hub Central. Awesome. They were very excellent questions to ask. We have one more kind of graph that I want to talk about. Okay. Here is my one more kind of graph, and it's going to be based on this data. This data is measured on the Old Faithful geyser in Yellowstone National Park in the USA. What happens is this geyser, every 10 minutes or so, spits out a jet of superheated water, and this is how many seconds it's shooting water out for. So it shot out water for 3.6 seconds, then about 10 minutes later it shot out water for 1.8 seconds, and then about 10 minutes later it shot out water for 3.333 seconds, and so on. And we've got 272... I can't concentrate. We've got 272 bits of information there, and I can, I'm going to draw a scatter plot, which was the wrong thing to do, but it does show me something. So this is which row of the data it is. So the first eruption was there, and the first eruption was there, second eruption's there, third eruption's there. Each eruption, the time it is, and even in this graph, I can tell that most of the eruptions are around 2 seconds long or around 4 seconds long. I can tell that from this graph. It's not the graph I really wanted to draw, but it does actually tell me that information. But what I would prefer is something that didn't have this on it here. That's not something that was particularly helpful. So what I'm going to do is I'm going to turn this graph sideways, and notice that here between 1 and 2 seconds there's a certain amount of data. Here between 2 and 3 seconds there's slightly less. These are all possibly even the same. Here between 3 and 4 there's a certain amount of data. Here between 4 and 5 there's heaps of data there. And I would like to draw a column for each of those categories for how much data is in there. And that's called a histogram. Now I could actually attempt to count those things myself and create the data myself and get it to draw a bar chart of that, but Excel already has a functionality which is slightly dodgy but works okay. It's called a histogram. Now if you look extremely closely at this histogram, you will see that it's saying that between 1.6 seconds and 2.22 seconds there's like about 75 bits of data in that spot. So it is more likely to be here or here, but those categories are a bit weird. So I'm going to explicitly tell it to draw them in a different way. I'm going to click on that, go to format this selection, and I'm going to specifically format the horizontal axis. So when I do that, I can choose the bin width to be, let's say, about half a second. And now that does this. But it's still starting at 1.6, which is the shortest number. And so I really wanted to start earlier, wanted to start at one of the grid marks, like at 1, I'd prefer. So if I started at 1, the next one would be 1.5, which is still too low. I can actually tell it. The underflow bin here is the first bin, and it'll just say less than that number. So I'm going to say which ones are less than 1.5, and it's still not working because that's still too low. Which ones are less than 2? There we go. Now this is saying these are the ones that are less than 2. These are the ones from 2 to 2.5. These are the ones from 2.5 to 3. This is 3.5 to 3 to 3.5, 3.5 to 4, 4 to 4.5, 4.5 to 5, 5 to 5.5. And that feels like a nice a way of arranging the bins. It would be really awesome if Excel could just get you to list where you want the separations between the bins are, which is what R does, but it just doesn't do that. Because Excel is not just really, I mean, this is this has only been introduced like in the last couple of years. Excel is designed to draw line graphs for categories. It's not designed to do histograms. They've only just added that on because everyone wanted it later. But everyone wanted this 20 years ago and they still didn't do it until now. Okay, so I'm just going to say something that I could choose my underflow bin to be 3, but that's a bit confusing because everything less than 3 is in this blob. So you have to try and arrange it so that there's only one category before that. All right, what I'm going to get you to do is not use the computer yet, but please oh, damn it. I want you to think about the box office takings of your movies, and I want you to draw a histogram with your cards. You get to choose what your bins are. So choose what you think the box office takings ranges are going to be for stacking up your movies.
Is it every 4 years?
Yeah.
So then we do.
This is me thinking, trying to go, when was the last?
The last one was Dash, what is it?
What about this time? We have to 2022. We have to vote on it.
Oh my god, that was an hypothetical question. Yeah, you do. Oh, it means you don't care.
Oh, no.
Right? Green team all the way.
You do, yeah, you do in federal judge. But you don't in local.
I go to the one of those. I know all the people. You can vote for them. You don't have to vote. Okay.
But no one's telling you. Yeah, Jesus.
Everyone's going to do 5.
Shazam's 360. Like a lot of things. Wow, we have, what's the I thought we were doing 200.
0 to 200.
Oh, wait, yes, it's
Everyone is pretty much ready. If you've drawn yours, can you go have a look at what everyone else looks like? But if not, finish yours.
Come on, let's go.
What are your bins?
500 increments.
Awesome.
Yep. Yeah, it just he's giving it a squeeze.
Cool.
Everyone's the same.
Yeah.
You've got a gap.
They just scroll for the one.
Yeah, they re-release it.
Avatar, like the blue people.
Like the movie, the movie Avatar, it's just the whole story behind it. is. Like, I've seen a comparison and it's such a light saviour. It's so, yeah. Okay, on one hand it's a Disney movie, but it is so close to your face. Yeah. So she was supposed to be the princess of the tribe, and there was being oppressed by white settlers coming in, and then, you know, this soldier then... Okay, you know Dances with Wolves? Okay, you're basically all these movies where you've got native people who've been oppressed, and then one of the oppressors realises the error of his ways and then goes and saves them.
We started our son like, oh, this. I finished that. That's why I always just say having a
All right, I think that's enough. Sit down. And while you're walking, I want you to think about whether you saw one that was different to yours. Because you should have. So, could the groups who chose 500 million wide bins stick their hands up? That was a really common choice. Why did you choose that? It was easy. That's not the worst choice to do easy ones. Could a group that didn't choose 500 million wide bins tell me what they chose? 200? Ah, did anyone else do 200? Ah, yay! So exciting. Okay, so what did yours give you any information that the 500 wide bins didn't?
More specific, so within 6 to 8, there was probably the most, and between 8 to 1 billion was equal.
Okay, so you know that between, I'm just going to repeat that to make sure I got it, between 6 to 8 and 8 to 10 in 100 millions, you could see that they were the same amount, but those guys just had one big bar for that. Okay, so choosing the different bins gives you different information. These guys have, what was yours, 100? These guys have 100 million, and so you can see with that one that there's a clump specifically at a specific spot, but most of the rest of them are really spread out. And so it's a choice you get to choose with histograms how many bins there are, and there's a choice between being able to see how spread out the data is and having it two clumps together, and you've got to choose. Most people choose about 7 to 10 bins, choose their number based on that. There was a group here who suggested having a 200 million wide bin, and I really wanted them to do it. It would be stupid, but it would tell you that there's a whole lot here and then 2 here. That would have been cool. But they weren't brave enough to do that, and I understand why. And maybe they went, that doesn't tell me anything useful, and that's probably the most productive thing to have done. Okay, so you can choose those bin widths in Excel if you want and change them and get a different thing. But I'm going to have to change that undeployed bin to now 1 point. Yeah. So, and you can get slightly better information if there's enough data. If there's not enough data, if you have the bin's too small, then there's only one thing in each bin and it doesn't tell you anything. Okay. So, that's pretty much the end of what I wanted to say. Oh crap, no, it's not. You can download the superhero data and make a graph of your own on the computer. Yay! Do it! Yeah.
No, we were.
So you can do that, just one person in the whole team doing it, or you can all give it a try.
Access when we started. I get confused because I'm so used to 2 to 5 and I've got to like transpose that to 11. So no, you're actually.
I hate Excel. I hate Microsoft. They started charging me a bunch of buttons, so you get them green. Do I? Do it? I've been pages and up since day one.
Are you serious? Okay.
I've been using pages. We get it for free.
You get everything for free in uni.
It's like,
So what's on graphical like?
I could just see you were doing it and you're looking at me as you said that just to see my reaction.
and you get all of the Microsoft things. What is this? You get everything.
Do it now?
Can I print? I don't know how to print. I don't know.
I know how to print.
I downloaded something like that. I can't find it.
Don't do it with your laptop. Just do it.
Because I can't print.
No, you can do it from your own.
I know, but it's just outside.
But once you've installed it, then it's installed.
I tried to
forever.
install it and it went missing.
Same. It like really messed up my whole laptop. I was like,
Do not have Word.
You don't, no, so if you go up to, you know where the Ask Adelaide is?
oh no, I'm just nervous to ask you for help.
That was
Yeah,
installing
it's
this.
probably, but no, installing any of the software that you guys
Are they
get for free.
friendly?
What? They are.
They don't drive me crazy.
They are.
I feel like that'd be
No, you'd be like, can you help me? And they'll be like,
They're used to.
exactly, they're used to it. They'll be like, another one.
Lost confused people. No, they are important. They're really nice people. Yeah.
just because I feel like
Did you promise that? Because it won't come back, right?
Yeah, I promise.
like I guarantee.
Yeah.
How's that graph?
That looks horrible to me.
You look like I'll do it.
Where's your will be? Oh, why did your
That actually made me giggle so hard.
And 3, 4, 8.
See, that's just so ready for it.
We are. But that could have offended him. Did that offend him?
Why would that offend him?
Oh, now you asking whether or not that would offend him could offend him.
Okay, so we've got the bar graph.
Stay. Oh, because of group.
I don't know.
Nothing.
You've definitely been
Contributed so much. So how's that?
Is that horrible, that movie? Or not? What about the Wasp? Where's the Wasp? Is he a bad guy? The Wasp is his girlfriend.
The wasp is in
And she also
Should we? Wait, what's his name?
Cast the director.
Is he actually? No, Robert Pattinson is.
You had no idea that whether or not it's an athlete, but you know if it's Robert Pattinson.
Then I'm going to go to Lordville. I know my stuff.
It's the Wasp. So what are you doing?
It should be the wasp. Oh, you guys have seen this song?
It's other murders.
What? I don't know. I haven't seen it yet. They like go around to this. I don't know. There's like this one festival. But it turns into a whole. I've seen it. Yeah. Yeah, I've seen it. I don't know. I've seen it. What was it? No, literally, where? Why did you watch it when you should have done this? Oh my God, say it again. No, you.
Well, that was. Thank you, everyone. Everyone's drawn a graph, and I'm very proud of you. And you can play with that to your heart's content. And we have all discovered that the histograms in Excel are slightly annoying, and that's because Excel is only designed to draw column graphs with categories, and there you go. But that's fine. It gives you at least a good idea. I have one last thing to say before I go, which is maybe you don't have to necessarily write them down, but for 30 seconds without talking to anyone, think of something you'd like to remember from this session. And then, after a little bit of silence, discuss it with the other people on your table. And while you're thinking and talking, you could pack up your cards so that I can collect them.
There we go. Yeah, we're getting it earlier. Certainly tells you the relationship.
Oh wait, there is a video.
Well,
Thank you for having me, everyone. I hope that you have something that you can take away from this. And if I see you in the Maths Learning Centre, I'll be very excited that you've asked for help. And if I don't see you, I'm going to assume that you are perfectly okay and you don't need anyone, which that's not true. So I'll just assume you're doing fabulously if I see you in the street and I don't see you in the Maths Learning Centre. Okay? So good luck this semester. You don't need luck. Work on stuff and ask for help.
Wait, don't go anywhere.
Because Andrew has stuff to say.
Yeah.
See ya.
Well, it was going to be quick, but then someone went, really? So I'm going to take my time. And it was someone sort of over that way. Okay, I'm not going to talk for long. When, like, watching this is